Hello, my name is Daequan.
Hello, my name is Brant.
My name is Luis Henry.
For this project, we had to do a design packet, which would state all the things we needed to do for our spaceship. And the main design challenge for this was design and build a prototype radiation shield that effectively blocked stimulated space radiation using materials that could safely fly the Orion crew model.
Step 1 was identify the problem. State the problem clearly. NASA is sending astronauts into space and we need to protect them from cosmic radiation.
Okay, for our design challenge, we had to build a spacecraft model off the Orion, and we had to find something that would block the most stimulated space radiation. So our problem for our experiment was which of the materials will block the most stimulated space radiation, and which material will keep the UV beads inside the spaceship at a normal white color, at a clear color. And the hypothesis was if we use clothespins, pencils, hot glue, tape, bottle caps, and tag board and aluminum foil, then it will be able to block the sunlight from reaching the UV beads, which is radiation from the sun, which is the UV rays. So hopefully all of our hypothesis stated that everything we're using on our spaceship will block the stimulated space radiation from the sun.
For our NASA challenge, we also had to make a reflection log about what we learned and what we had to work on from the past week. After week 1, we learned that our group learned that last week some of the materials we were thinking of using for our model weren't going to work. Then we learned that our first design was not a good, solid structure, so we rebuilt it. We used connects to build a spacecraft. So when we build our real model, we can look off the connects. It was basically like a blueprint. The learning target that we needed to work on was build a prototype that can withstand radiation, energy, and drastic temperature changes. That's what we're working on right now. And also, we need to utilize technology to measure heat transfer and a variety of substances.
Alright, so this was for our second week of the project. What did you and your group learn this week? Well, we learned that our first design wasn't going to work as a prototype. So we decided to make a new prototype out of clothespins, glue, tape, and pencils. This was a great idea because yesterday we tested it in all of our model, and it was very sturdy. The materials were light, they were all pretty cheap, and they did not burn when we lit them on fire. The materials, they kind of singed, but they didn't catch fire, and when they did singe, they didn't singe for a long time. They singed for a few seconds at the most. Our learning target we needed to work on that week was building a prototype that can withstand radiation and drastic temperature changes. We were testing the huge temperature change from just normal room temperature to the fire. We had set fire to our spaceship, so it held withstand pretty well against the huge change in temperature.
Depending as your content.
Okay, week 3 we learned that some possible solutions to shield cosmic radiation are plastic, condoms, or balloons because they have high hydrogen content. Second, the learning target we needed to keep working on was build a prototype that can withstand radiation, energy, and drastic temperature changes. We need to work on this because we really haven't picked our material we want to use to block cosmic radiation. We've just sorted out some things that we may use, but we aren't completely sure what we're going to use.
Alright, so for the fourth and final week, what did you and your group learn? Well, we learned that we couldn't use a balloon for our spaceship. This balloon would not expand enough for us to insert our spaceship, so that we wouldn't be able to use that. But instead, we decided to use tag board. We found out that tag board was really good at blocking stimulated space radiation by inserting UV beads into the tag board. Then the tag board, we put a purple light next to the tag board, and it did not change the UV lights at all. Secondly, we decided to add aluminum foil to the tag board, and that helped even more when the weather when it would rain. It helped keep the spaceship dry, and it also blocked out the stimulated space radiation from the sun that we let sit outside for 3 days. Identify the learning target you need to keep working on was build a prototype that can withstand radiation, energy, and drastic temperature changes. We used the same learning target for all 4 weeks, only because we weren't 100% sure on what we were going to use to make our finished model.